Hello everyone, welcome to Tech Systems. In this video, we will talk about BACnet IP. After watching this video, you will learn what is BACnet IP and what are common terminologies related to the BACnet IP. BACnet IP is an implementation of the BACnet protocol using IP, which is Internet Protocol. Use of IP allows BACnet to span across multiple physical and logical network segments. BACnet IP uses UDP instead of TCP protocol. UDP stands for User Datagram Protocol, which is a connectionless protocol. BACnet IP defines 16 UDP ports, which are written here. These ports are 47808 to 47823 in decimal notation, while the hexagonal notation is also written here, which is BAC0 to BACF. BAC0 or 47808 is the default port defined by the BACnet IP. So most of the time you will see this default port being used with the BACnet IP devices, while other ports can also be used if required in some applications. Apart from UDP, each BACnet IP device is also assigned an IP address. BACnet standard use the concept of MAC address to identify the devices on the network. For BACnet IP, MAC address is defined as a combination of IP address and the UDP port. It is also known as BACnet device address. For example, here is a BACnet IP device address, where this part is an IP address while this is a UDP port. So combination of IP address and the UDP port is known as BACnet IP MAC address or the BACnet IP device address. Same UDP port shall be used by all BACnet IP devices on a network in order to communicate with each other. Usually the default UDP port is used for all the BACnet IP devices. If you want two different groups of BACnet devices to exist on a same IP network, then you can use different ports for these devices. For example, if we have a group of devices dedicated for the HVAC control and another group of devices which are dedicated for fire alarm system, and we want both devices to be separated and we don't want them to communicate with each other, then we can use different UDP ports for these devices. For example, we can use 47808 for the BMS or HVAC control devices, and we can use 47809 UDP port for the fire alarm devices. In this way, these devices would exist on the same IP network, but they would be two different BACnet networks, and these devices would not be able to communicate with each other and they will not interrupt with each other. So in this way, on a same IP network, we can have two different BACnet networks with different UDP ports, and these devices would not be communicating with each other. As we just discussed, each BACnet network have a network ID or a network number. A BACnet IP network can consist of a single IP subnet, or it may span across multiple physical or logical IP subnets. Two or more combined BACnet networks form a BACnet internetwork. To understand about BACnet network and internetwork, let's consider an example. Here we have a BACnet IP network with network number 1000. Now suppose we have BACnet MSTP devices which are connected on a segment and are connected to the IP network through a BACnet MSTP to IP router. Now this BACnet MSTP is a separate BACnet network with a network number of 2000. So here now we have two different BACnet networks. One is IP network with the network number of 1000 and another BACnet MSTP network with the network number of 2000. These both networks combined form a BACnet internetwork. Now let's go into more details about a BACnet IP network existing on a single IP subnet. Here we have BACnet IP devices connected to a single IP network. We have two BACnet IP DDC controllers which are connected to the network switch through a Cat5 or a Cat6 cable. Then we have a graphic workstation which is also connected to the same switch. Each BACnet IP device uses an IP address Consider that we have an IP network with this subnet of 255.255.255 and our IP network is 192.168.1.0. This subnet means that we can have 255 hosts or devices on this IP network. Let's suppose we have assigned these IP addresses to all the devices and also we are using default UDP port for the BACnet IP communication. Here we have assigned .2 IP address to DDC1, .3 to DDC2 and .4 to the workstation, and we are using same UDP port for all the devices on this IP network. Apart from the IP address, each BACnet device is also assigned a device ID, which is also known as BACnet device instance ID. This device ID must be unique over the complete BACnet internetwork. If a duplicate device ID is assigned to devices, these devices would not be able to communicate with each other. So always assign unique IDs to all the BACnet devices on a complete BACnet internetwork. Each BACnet network also have a network ID. Here we have defined 1000 BACnet network number for this network. BACnet devices don't need to know about the network number. Network number is need to be defined in the BACnet routers, and also it is defined in the workstation for configuration of the BACnet network driver. This is an example of a BACnet IP network which spans across a single IP subnets. Now consider the case where BACnet IP devices are connected on different IP subnets. These IP subnets are connected together through an IP router, which helps in communication between these different subnets. Here note a very important thing, that although BACnet IP devices are connected to different IP subnets, but the BACnet network number is still the same. And BACnet network number in our case is 1000 and we are using default UDP port for all the devices. As shown here we have two different IP subnets. First IP network is 192.168.1.0 and another one is 192.168.2.0. On first network we have two DDCs which are DDC1 and 2, while on another IP subnet we have another two DDCs which are DDC3 and 4. As you can see here, we also have a router between these two IP subnets. This router helps in communication between these two networks. Two IP addresses are assigned to this router because this router contains two network cards and each card is defined an IP address. So as you can see here, we have defined 192.168.1.1 and 192.168.2.1 to this router. As we know that BACnet uses broadcast messages like who is and who has to discover devices or objects on the network. These broadcast messages can travel on the local subnet without any issues, but most IP routers don't allow broadcast messages to pass through them. So BACnet broadcast messages would not be delivered to the other IP subnet. To resolve this issue, BACnet standard introduced BBMD or Broadcast Management Device. A BBMD must be present on each subnet. It is not necessary to purchase a separate BBMD. Usually BACnet IP routers and building controllers support the BBMD functionality, and we can configure BBMD functionality in these controllers or routers. Now let's see how BBMD functions. Suppose workstation has initiated who is broadcast service. This message will broadcast across all devices on the local subnet. After receiving the broadcast message, BBMD will transmit it to the BBMD on the other subnet as a unicast message. Then this BBMD will again broadcast this message on its local subnet. In this way, broadcast messages are transmitted to the other IP subnets. Each BBMD device contains a BDT, which is a broadcast distribution table. BDT contains IP addresses of all BBMDs on different IP subnets. Each BBMD must contain a same BDT. BDT is manually configured for all BBMDs and it is not self-learned. Here is an example of a BDT table for the previously discussed BBMDs. As you can see here, we have different entries in the BDT table. First of all, we have the IP address and UDP port and the broadcast distribution mask. So 192.168.5 and 192.168.2.5, these were the IP addresses for our BBMDs. So each BBMD will contain a same BDT or broadcast distribution table. Now let's see what are different types of broadcast messages. First of all, we have a local broadcast, then remote broadcast and global broadcast. A local broadcast message is a message sent from one device to all other devices on the same BACnet network, while remote broadcast is a message sent from one device on one network to all other devices on another BACnet network. While global broadcast is a message sent from one device on one network to all other devices on all BACnet network. So guys, that's all for this video about BACnet IP. I hope this video will help you learn more about BACnet IP, and it will help you to understand and troubleshoot your BACnet IP networks, and it will also help you to configure your new BACnet IP networks. If you find this video useful, please like this video and subscribe to my channel.